So just a quick background about myself. So I'm part of the Dex team at Gnosis, and I do business development and contribute to product architecture design. Previously, I worked at a crypto trading firm, doing some prop trading, market making, deploying various strategies. Yeah, so this is a quick background. Let's jump right in. So recently there have been vibrant discussion around the efficiency and the long-term viability of AMMs. Probably thanks to the recent success of the AMM model, increased capital deployed into those liquidity pools and increased volumes. So in this presentation, I want to go into the differences and similarities of AMMs versus order book exchanges, how they work, and some advantages and disadvantages of each of those approaches. And finally, I would like also to present a preview of the Gnosis protocol version 2 and explain how it's designed, it's designed to tackle some of the issues and leverage some of the advantages that we'll soon talk about. So starting with a quick motivation, I gathered the market depth metric from Uniswap, Binance, and Coinbase. It illustrates the success of AMMs generally, and Uniswap here in particular. We can see that the market depth on Uniswap for the aggregated ETH USD pair. So I took the pools for ETH USDC, USDT, and DAI all together. And it's order of magnitude higher than on traditional order book exchanges like Binance and Coinbase. In practice, what does it mean? It means that for large players that want to execute big trades without impacting the market too much, they would look at this metric, and it means that on Uniswap you can execute $17 million trade with moving the price only 2% up or down. And on Binance or Coinbase, that number is only $1 to $4 million. So a significant lead to Uniswap, at least currently. And this is very, very impressive achievement. From here, I want to jump and explain a little bit about order book exchanges, how they work, and how liquidity works on order book exchanges. So here you can see in the slide the order book, live order book of an exchange, and the order book exchange operators keep all limit orders in a list, which is called the order book. And when a new limit order arrives that is overlapping an existing order in price, so if someone wants to sell an asset for $100 and someone else is willing to buy it at a higher than $100, obviously a trade could happen. So the exchange operator will match those trades and those orders, and it will result in a trade. So those are two of the functions of exchange operator. They keep the order book updated and match trades. And you probably know that centralized crypto exchanges often do also trade settlement and custody of user funds. But this is not the case for decentralized exchanges, and actually it's not the case also for traditional exchanges, where there's a different party that does custody of funds and also usually settlement. So how liquidity works on order book exchanges? The ability of participants to trade in this kind of market is heavily dependent on other participants filling the order book with bids and offers for the traded asset. so who are those players that make the order book liquid? It could very well be just an individual trader that want to execute a specific trade at a specific price and just submits his limit order into the order book. But usually it will most probably be a professional market maker that will provide bids and asks into the order book and make the pair liquid. Market makers usually can make money when there's a lot of trading volume, but the price is not moving is not moving a lot or not changing a lot. A friend of mine that is an experienced algo trader once told me that being a market maker is a little bit like standing in the middle of an highway and trying to avoid being overrun. And what he meant in this quote is that market makers, although they are able to make decent profits sometimes, they also bear significant risks, and they need to hold inventory of both assets. They are providing liquidity too, and when the price moves to either direction, up or down, they are usually getting exposed. So they will sell the asset that is appreciating, but buy the asset that is depreciating, and this will result in a loss on their balance sheet. And this is where traditional market makers usually specialize. So they have various techniques and algorithms and very high, very low latency connections to try to avoid those kind of losses, and hedge their position and try to remain as market neutral as possible. And later on, when we'll talk about, we'll refer to this kind of losses also as impermanent loss. So in the context of AMMs, usually it's called impermanent loss, but it's essentially very, very similar. So if we talk about order book exchanges in the angle of decentralized exchanges, one of the earliest attempts at building such an exchange was Oasis Dex by Maker, and they took kind of a naive approach and were trying to replicate a traditional order book exchange, but they did it all on chain, and it turned out to be a little bit costly and high friction for market makers to try and make the book liquid, because they had to pay for transaction cost every time they want to update the order book. And this is exactly where AMMs came into the picture. So what are AMMs? They stand for Automated Market Maker, and AMMs they replace the notion of order book with a different approach to providing liquidity. Liquidity providers, in short LPs, are a type of participants in AMMs, and they just provide both assets of a trading pair into one big liquidity pool. And they basically replace the role of a market maker in the traditional sense by agreeing to be the counterparty for every incoming trade that is coming into the AMM. Usually AMMs use a deterministic price rule to determine the market price at a specific point at any point in time. And for Uniswap, for example, this is the constant product formula. And how it will, in a very simple example, how it would work. The contract knows the state, so it knows the amount of A tokens and B tokens in the pool. And assuming I would want to trade 100 A tokens for B tokens, it already knows the future state of A, so it's the previous one plus 100, and yeah, then it becomes pretty trivial to solve this and know what is the price or how many B tokens I should get back from this trade. Other AMMs like Curve, for example, they use different kind of formulas, and they optimize for a specific for certain use cases. So this approach makes it extremely easy to provide liquidity to AMMs. So you don't need to be like a professional, market makers in traditional order books. Anyone can just provide the tokens into the pool and participate as a market makers. But it also carries some risk. So as we earlier talked about impermanent loss, LPs that provide liquidity, they can capture the fees, but they also, if the price moves, they will be subject to impermanent loss. And in order to overall make a profit, they need the fees to overcome the impermanent loss. Yeah. So talking a little bit about some innovation in this space and how new projects try to make this model of AMMs more efficient or more suitable for specific use cases. So Curve and Shell protocol, for example, both use a hybrid formula, and this optimizes for trading of assets that are expected to trade at a 1-to-1 ratio. And with this assumption, they can really achieve much higher liquidity with lower amounts of assets locked in the pools. And so this is a great use case, and it's already widely used. And another example is Cofix and Dodo. Both use price feeds to update the market price. So in contrast to the more traditional AMMs that update the price only when a trade happens, those exchanges can update their price using the price feed even without any trade happening, and this increases the efficiency, and they can provide a much higher liquidity with a lower amount of assets in the pools. They are also subject to front running of those price feeds, so it's not everything is not solved yet, but yeah, those are some of the innovations. I can't go into all of them, but I encourage all of you to go and take a look and learn about them. So to summarize this part of the presentation, I would like to go a little bit into the comparison between AMMs and order book exchanges. So AMMs excel in some areas. For example, AMMs were able to overcome Ethereum's latency and cost of transaction, which early decentralized exchanges struggled with. So they are very suitable for this kind of environment. They also provide universal access to trading fee revenue. As I mentioned earlier, it's risk bearing, so it's not risk free, but everyone very easily can provide liquidity and be exposed to revenue from trading fees. Liquidity is always available to traders, and I also added here some quotes from AMM proponents. For example, Dan Robinson. So he said that volatility harvesting, which is essentially the strategies that LPs use, it can be a profitable strategy, and AMM liquidity providers is a brand new retail financial product. So those are some of the advantages of AMMs over order book exchanges, but Orderbook exchanges also have some advantages. AMMs does not allow for active market making, and Orderbook exchanges does. So market makers can optimize and provide liquidity in a much more efficient way and hedge the risks appropriately. So AMMs are capital intensive. If you remember the example I gave in the first slide, where the market depth of Uniswap is very liquid comparing to Orderbook exchanges. This comes in the cost of $1.5 billion locked in those 3 pools. So it's very, very capital intensive. So this is a disadvantage of AMMs versus Orderbook exchanges. Usually the fees on AMMs are high, and I think this comes to compensate for the risk of impermanent loss. AMM critiques would say that AMMs are inefficient and they can't scale. For example, some from Alameda, he said that the past is Orderbook, and so he thinks the future. And yield farming artificially inflated the total value locked into the pools, and thus volumes and usability increased, but they claim it's not sustainable long term. And impermanent loss is an intractable problem. It's not seems reasonable that it will be eliminated entirely, although hopefully maybe reduced a little bit. So those are some of the disadvantages of AMM versus Orderbook exchanges. And now with this in mind, I want to go into Gnosis protocol and look at how we try to leverage some of the advantages and try to mitigate some of the disadvantages to make a very efficient trading protocol. So I want to start with a simple example. Imagine you're standing in front of a currency exchange, wishing to exchange some cash for your next travel. And you see the exchange rate at the screen, and you see also the fee. The fee sometimes, or even usually, looks outrageously high in those exchanges, and you can just choose to wait a few moments. And if by any chance another person comes and wants to do the counter trade, you can agree to do the trade at exactly the exchange rate of the currency exchange, but you just don't need to pay the fees because you do it directly with each other. So this is exactly the concept of Gnosis protocol. We use batch auctions to achieve this, and obviously there's also you don't know if always you would find the counterparty, or if your counterparty would want to exchange exactly the same amount as you. So there's some complexity here, but this is the general idea. I wanted to talk a little bit about our experience in building decentralized exchanges. So in 2018, we launched DutchX, and in DutchX, we implemented a Dutch auction mechanism, and it's intended to find a fair pricing for even a very illiquid assets or very large trade sizes, and there's some nice qualities like uniform clearing prices and front-running resistance. And even today, Dutch auctions are used in DeFi mainly to do very, very large trades or liquidations. But the auction time is usually long, so it's not very suitable for everyday trading. So in 2020, we launched Gnosis protocol. And Gnosis protocol uses 5-minute batch auction mechanism, and it still uses uniform clearing prices and front-running resistance, and it also enables routed trades. So if you want to trade one asset to another, you could route the trade through other tokens where the best liquidity for you. Yeah, and now taking the experience from those two exchanges, DEXs, we're now in the progress of designing the next version of Gnosis protocol, and it would take still most of the first version qualities, but I'll try to describe how it works and yeah, emphasize the benefits of that we add in the second version. So batches, still there are batches which are just the time windows where user orders are collected, and in these time windows orders are not settled, they are just collected. And this what enables to find this coincidence of wants between users, which is kind of should be one of the most efficient ways to trade, because you don't need the liquidity of a counterparty that bears some risk providing this liquidity. So batches will be 1 minute long, and users will submit the orders into the exchange, and those will accumulate in those batches. The order book will be now off-chain, so it will be very performant, and market makers can provide quotes very easily, making the order book already liquid. And once the batch is closed or is about to close, also the aggregated AMM liquidity will be taken into account. So first of all, usually the coincidence of wants will most probably win and give the best trade prices. But if prices are better for some reason, or there is no counterparty for a specific trade, it will be sourced from the aggregated AMM liquidity, so very similar to DEX aggregators today. So you can think about it like another layer on top of AMMs, where we enable this coincidence of wants to occur, and to have like better efficiency, lower trade fees, but still where it's needed or where it provides value to use automated market makers. I have here another slide that might help understand this. So consider first the Orderbook Exchange, where, for example, Alice would like to trade DAI to YFI, and Daniel would want to trade YFI, but not exactly to DAI, but to ETH. So there is some overlap of their wants, but they are not trading in the exact same order book, so their orders can't be matched, and those order book exchanges will not use external liquidity like AMM liquidity to help match those trades. So it's just not possible to execute this kind of trade. And in AMMs, both of them will be able to execute their trades against the available liquidity, but they will not leverage the coincidence of their wants. So for example, Alice will most probably need to go through the ETH liquidity pools, because those are usually the highest liquid pools, and she will first exchange DAI for ETH and then ETH for YFI, and this will cause twice the 0.3% trading fee. So it's not that efficient, but it's still possible. And with Gnosis Protocol version 2, both of them could leverage the coincidence of wants between each other, but still, because if there is a need for an external source of liquidity, so the AMM liquidity of ETH DAI could be leveraged to complete this trade, and this will incur the decreased trading fees and higher efficiency for the trade. Yeah, so I want to summarize what we've gone through here. So I think AMMs are innovative trading product, and they, in my opinion, they will probably continue to evolve and improve, and they are essential part of the Ethereum open financial layer. And in Gnosis Protocol version 2, it's designed as a settlement and liquidity layer on top of automated market makers, and it will use automated market makers when they provide benefit to the users. But it will also enable users to directly trade with against each other, and leverage the coincidence of wants if there is such a thing. Yeah, we also changed to an off-chain order book, which allows much better and efficient market making, and the user will be guaranteed to get at least the aggregated automated market maker price at the time of settlement. And yeah, the exchange still keeps the properties of uniform clearing prices, so it's a fair pricing. Everyone in the same batch will get the same price, and in contrast to AMMs, that even participants in the same block will get different prices, and it will be front-running resistance at least to a certain level, because the liquidity that is sourced from AMMs might still be front-run, but yeah, trades between two parties will not be front-runnable. So those are some of the advantages here. Thank you for listening, and please, if you have any questions now, happy to take them, or if you want, please join our Discord, and we'll be happy to provide more information and answer your questions.